Welcome to cryptography session. Today I will give an example for Eulers theorem problem. Eulers theorem is applicable to mod value of composite number. Fermat theorem is applicable for mod value of prime number. So you just go through the value of n at right side. If n is prime number, you apply Fermat's theorem. If n is a composite value, apply for Eulers theorem. That is only the difference. So we just carefully note it out the n value. According to the n of a prime or Fermat's prime or composite value, either Fermat or Eulers theorem may be applicable. So if you take Eulers theorem, the first version is a power pi of n mod n is equivalent to 1. We already know that pi of n is Eulers torsion function, and we calculate the pi of n at 4 rule by applying 4 rule. The first rule is pi of 1 is equal to 0. Second rule, pi of p is equal to p minus 1, where p is a prime number. Third rule, pi of m into n can be rewritten as pi of m into pi of n, where m and n are relatively prime to prime. Then fourth rule, pi of p power e is equal to p power e minus p power e minus 1, where p is a prime number. So we by applying those 4 rules, we may able to calculate pi of n. And second version is a power k into pi of n plus 1 mod n is equivalent to a. So this Eulers theorem is applicable for the calculation of RSA crypto system. Because in an RSA crypto system, we should take two numbers. Those two numbers should be multiplied. So there is a composite possibility is available. For the composite possibility calculations, we should apply this Eulers theorem. Let us take an example for proving it. Find the result of 6 power 24 mod 35. So here we may able to take, it is a generalized form. So now n is equal to 35. It is not prime. So we should apply Eulers theorem. If you want to find out Eulers theorem, first we should calculate pi of 35. So pi of 35 means pi of 5 into 7. That can be rewritten as pi of 5 into pi of 7. So answer for pi of 5 is 4. Answer for pi of 7 is 6. So 6 into 4, 24. So the general format of version 1 in Eulers theorem is a power pi of n mod n, that should be equivalent to 1. So in this general format only, the given problem is available. Here a is 6, pi of n is 24, n value is 35. So the answer for the first one is, by applying version 1, answer is 1. If we take the second problem, here n is 77. It is also a composite value. We should calculate pi of n. So pi of 77, that is pi of 11 into 7. That can be rewritten as pi of 11 into pi of 7. Answer for pi of 11 is 10. Pi of 7 is 6. So 60. But we should take this version 2. Version 2 is a power k into pi of n plus 1 mod n, that should be equivalent to a. Here the answer is 62. If we take k is equal to 1, pi of n plus 1 is 61. So this 62 is splitted as 20 power 1 mod 77 into 20 power pi of n plus 1 mod 77. So by applying version 2, the answer for this one is 20. 20 mod 77 is also 20. So if you multiply these two values, the answer is 400. But if we take the problem, we are calculating the remainder value of 77. So the possible remainder value of 77 is from 0 to 76. But I have the resultant value as 400. So it is not within this range. So once again, we should calculate mod 77. So the answer is 50. So in this way, we can be able to apply version 1 or version 2 of Eulers theorem. So in this theorem also we may able to find out the multiplicative inverse. So the formula is a power minus 1 mod n, that can be calculated as a of pi of n minus 1 mod n. So like Fermat theorem also, we should multiply a at both ends. So it can be rewritten as a into a inverse mod n, that should be equivalent to a into a power pi of n minus 1 mod n. So the answer for left side is 1, that should be equivalent to a into a power, this is a power 1. So it can be rewritten as a power pi of n mod n. So by applying version 1, the answer is 1. So the LHS and RHS values are equal. In this way, we may able to calculate the inverse value of the given number also. So 8 inverse mod 77. So 8 inverse means if you multiply 8 and 8 inverse means here I am taking the multiplicative inverse of 8 is x. So 8 into x mod 77, that should be equivalent to 1. So we should substitute x value as 1, 2, 3, 4 like that. So at that situation, if you multiply 8 into 29 and if you do the modulus operation of 77, the answer will be 1. So the answer for 8 inverse mod 77 is 29. Like that we may able to calculate 7 inverse, 60 inverse, 71 inverse of given value. Thank you.